Welcome to Học Tiếng Anh với Joseph, where we build vocabulary and practice pronunciation through reading. Continuing with The Cat in the Box, A History of Science in 100 Experiments. Today's story is entitled The Importance of Nothing. One of the most important inventions of the 19th century, leading to the discovery that atoms are not indivisible, came about through experiments with the behavior of electricity in a vacuum. Julius Blücher, a German physicist working in Bonn in the 1850s, wanted to study electricity in this way and got his colleague Heinrich Geissler, a skilled glass blower, to make suitable glass vessels to use in these experiments and a pump to suck air out of them. Wires were sealed into the tube at each end, connected to metal plates, but with a gap between them. When they were connected to a source of electricity, usually an induction coil developed from the work of Michael Faraday, electricity flowed from the cathode across the empty space in the tube to the anode. This was like the way electricity flowed through a liquid in Humphrey Davy's experiments, even though there was only a trace of air in the tube. Blücher noticed that whatever it was that was coming out of the cathode made the glass of the Geissler tube glow where it struck, near the anode, and that the spot of light could be moved about using a magnet. He also discovered that traces of gas in the tube, such as neon or argon, made the whole inside of the tube glow with different colors, and was the first person to realize that lines in the spectrum of this light were related to the elements producing the light. Although he did not develop this discovery as fully as Robert Bunsen and Gustav Kirchhoff. By the 1880s, Geissler tubes were being manufactured and sold as ornamental devices for entertainment, a bit like the more recent lava lamps. They came in a variety of shapes, including helical tubes, one with several spherical bulbs ablaze along the tube, like strings of onions, and more fancy designs containing traces of different gases to make pretty colors. Early in the 20th century, it was realized that this could be adapted for commercial application, and by 1910, color tubes were being used in advertising signs. These became generally referred to as neon tubes or neon signs, even though other gases are also used in them. Meanwhile, science was developing the Geissler tube for other purposes. By the early 1870s, the English physicist William Crookes, based in London, had developed an improved version of the Geissler tube, which became known as the Crookes tube. The key improvement was that Crookes was able to evacuate his tubes to a lower pressure than Geissler, using a pump made by Charles Gimmingham. A Geissler tube operated with a pressure of the gas inside of about 1/1000th of the atmospheric pressure. But in a Crookes tube, the pressure could go down to a few hundred millionths of an atmosphere, nearly 100,000 times thinner than the gas in a Geissler tube. This made it possible for Crookes and other researchers to probe further into what was going on. As they pumped more air out of his tubes, a dark area, now known as the Crookes dark space developed near the cathode in the glowing gas. As the pressure went down, the dark area spread down the tube, but the glass behind the anode began to glow. The anode itself left a clear shadow in this glow with sharp edges. It was clear that something was being emitted by the cathode and that it must be traveling in straight lines to leave the shadow. That something became known as cathode rays, a name coined by the German physicist Eugen Goldstein in 1876. As more air was pumped out of the tube, there were fewer gas molecules to get in the way of these rays, so they could travel further before they hit one and made it glow. Eventually, at low enough pressure, they could travel in straight lines from the cathode to the anode, but many flew past the anode and hit the glass on the tube. A particular neat example of this was demonstrated by Plucker, who made an anode shaped like a Maltese cross that casts a sharp cross-shaped shadow on the fluorescent behind it. Practical applications of developments from these tubes in the 20th century led to the invention in 1906 of the vacuum tubes, electronic valves that preceded transistors in radio, TV, and other amplifiers, and later the cathode ray tubes that formed the screens of early televisions. In science, they were instrumental in the discovery of X-rays and the electron. Cathode rays are indeed beams of electrons, which are accelerated in a Crookes tube to a very high velocity of about 37,282 miles or 60,000 kilometers per second, which is roughly a fifth of the speed of light. Moving on to the vocabulary section. Behavior, glass blower, only a trace, ornamental device, spherical bulb, spherical bulb. Advertising, evacuate, 100 millionths. This is very hard because the word million and then th and then s in the end. So 100 millionths. Cathode rays, fluorescence, fast becomes fluorescence. Transistor, not transistor, transistor. Amplifiers, to amplify, amplifying, amplifiers. Thank you so much for making this far. I appreciate it. And as usual, I will see you in the next story. Bye for now.